Hello, everyone, and welcome to my presentation. Today, I'm going to talk about the lecture number 2 about thermodynamics that I have watched on YouTube in a channel of the MIT University in the US. So let's get started. Well, in this episode or in this lecture, the professor talked about some basic concepts. For example, the ideal gas. What is the ideal gas? Well, this is an expression or an equation that we can use to describe gases. And the thing is that it's really easy to use because only involves the most basic variables in thermodynamics, such as the volume, the temperature, and the pressure. The problem is that this is so basic or so idealistic. So for most of the gases, it's difficult or actually it's impossible to describe their thermodynamic characteristics by using this expression. Actually, the only gas that can be described by using this equation is the air. But imagine that you need to obtain the information about the steam water, solvent, benzene, and everything. It's going to be really, really difficult. So you have to need another expression or another method to find the solution or to find the information that you need in your research or your homework or your project. Then we have another important concept, equilibrium. Uh, I have talked about this in the last video, so I'm going to repeat the information. In thermodynamics, we only study the equilibrium. For example, the state number 1, the state number 2, and the state number 3, when the variables stop changing. And then the professor talk about the first and second lab. Well, here we have a mathematical expression for the first lab that says that the energy, the differential of the energy is equal to the differential of the work plus the differential of heat. So we could use the energy of a system to have work and heat. But sometimes the heat is a waste of energy. Yeah. Okay, and then the professor explained the Joule experiment. This is so simple. It's a really simple experiment, but it's necessary because with this experiment, we can describe this image. We're not using equations or concepts or math concepts, physics concepts, or chemistry concepts. So here we have an example of the Joule experiment. So, okay, so imagine that you have a certain substance in this side of the system. So you are going to notice that here in this side we have the molecules of the system. But what happens if you decide to quit this? This is an obstacle in the system. So you decide to delay this. Well, the things that are going to happen are the next. The atoms are going to move through the systems until they occupy the space, all the space, so that the volume is going to be bigger, but the pressure is going to be lower. You know, as I mentioned, it's so basic, so easy to understand. Basically, it's the same concept as the air in the air. The air is trying to fill all the spaces. So yeah, this is basically the same concept. But as I mentioned, with this experiment, You don't have to use math, physics, or chemistry. And then we have the second lab. Well, I have talked about this in the last video as well, but this is another easy concept to understand. Well, basically, we have the efficiency of a system. We have work, the work that is going to be developed by the systems, and the heat. So that you have to know that it's impossible to have an efficiency that is more than one or the same as one. Yeah, this case doesn't exist. The efficiency is always less than one because it's impossible to use all the energy to make work, and it's impossible to obtain more energy because practically you are saying that you're going to invent or you're going to create energy, which is which doesn't have sense, doesn't make sense. Sorry. And then we have the case of the refrigeration using the second lab. Well, this is the process that takes place in your refrigerator that we have at home in your kitchen. So basically, it's the opposite of the last thing that we saw. Sorry, we have here I have a mistake. Yeah, it's inverse. You have to know that W could be less than one, equal than one, or more than one. But that doesn't mean that we are going to create energy. This is just, actually this number doesn't have a sense, no, doesn't have a, well, the number has sense, but you have to check tables or information to know if you can say that the performance is good, bad, average. Yeah. So, and then we have the Carnot engine, which is an idealistic process when you are, that doesn't exist. Yeah, it's impossible to do this in real life because in this process you are going to take advantage of all the energy. And as I mentioned, it's impossible because even if you want to use your energy only for work or only for heat, the energy is going to be changed in work and energy, in work and heat. Yeah, so it's in, so yeah, this case doesn't exist, but it's the most idealistic case. Okay, I'm going to talk about grammar points that I have watched in the video and I have listened to. Well, the first one is the past modal. The professor said this expression, is curve only gone from the direction hotter to colder? He used an adverb here, which is interesting. Yeah, he talked very sophisticated. And then he said a non-phrase present participle in this phrase. In the process doing a certain amount of work. This is the non-phrase, which describes or gives more information about this, about the process that he was talking about. And okay, we don't have time, so it's time to cut it a day. Thanks.